Okay, I'm sorry, last time I didn't realize that I had actually 10 minutes extra for questions. And I just walked off. But seeing that you didn't really ask questions from Alvaro either, we didn't lose anything, right? So we're all good, okay? Do you have any questions from the last session? I don't care, it's too late anyway. So, I'm going to give you an introductory talk a little bit around functional programming and functional programming with Kotlin. How many of you here are doing functional programming? Right, so this would probably be the time that you should probably bring out the beers for them so they could go and drink beers while the rest of you stay and listen to me talk about things I have no clue on. So I'm going to start with something very, very simple, which is let me see, where is it that I have it? There you go. Let's take a look at this, okay? So now, what I want you to do is a little exercise. And that exercise consists of, as soon as you know what that does, raise your hands. You don't need to shout out what it does. I'm not going to quiz you on it. But as soon as you know what it does, raise your hands. And keep your hands up. Okay. Cool. That didn't take that long. Okay, how about this one? As soon as you know what it does, raise your hand. Right, much faster, right? Oh, and more people. Awesome. Okay, so you know what it does? Something. Well, actually, technically, they do the same thing. So when you talk about like why functional programming, I think that kind of explains it a little bit, right? It's about basically trying to make things a little bit more understandable and make code a little bit more readable. And I have to quote, I don't know if you know a speaker by the name of Kevin Henney. He talks about code being comprehensible versus readable, because everything is really readable. Right? You can read really, really rubbish things and it's still readable. Another thing is the aspect of it being comprehensible. So, but if you look at functional programming, one of the goals around it is to be comprehensible, to be maintainable. And so that begs the question of, okay, so what is exactly functional programming and what is a functional programming language? So who could tell me what a functional programming language is? Well, I'm going to make you talk today. You've been very, very quiet. You can't get beer if you don't participate. You said make this participative, and you've just been so quiet. Closure. What? List. Oh, you're naming functional programming languages. I thought you're looking for closure. I'm like, the elections already took place. No, anyway, the Closure, yes, okay. Closure is a functional programming language. What else?
Haskell.
Who? What? Haskell. Haskell. What else? Elixir. What else? Kotlin. Damn, man, if it wasn't, we would be really doing a bad job here, right? I actually, people ask me, like, you know, when I'm giving a talk to a group of object-oriented programmers, I always say, like, Kotlin is an object-oriented programming language with functional constructs. Now, if I'm in a group of functional programmers, you know what I say? I say, Kotlin is a functional programming language with object-oriented constructs. And it works, right? Because you please everyone. So, yes, Kotlin is a functional programming language. Otherwise, I would be really having a hard time being here right now. But what makes a functional programming language?
So you say you have an input and you apply transformations on it.
Okay, that's just one word too many. Well, what is transformations?
Functions.
A functions. Okay, what is a functional programming language? Something that has functions. Is that the definition? No. Okay, so what is?
There are some principles. The functions need to be pure.
Functions need to be pure. Does that make a function? So is Java a functional programming language? Is Visual Basic a functional programming language? You can have a pure function in Visual Basic, sure. It depends, right? If you ask a group of Haskell developers what is a functional programming language, what are they going to say? Haskell and only Haskell. If you ask a .NET crowd, they'll say F#. Are you familiar with F#? No, even Microsoft isn't. And it's another slide. Yeah, I know, it sucks, especially to the 5F# developers. No, there's actually more of them. I like to agree with Eric Meyer, who was one of the people behind C#, and he made, I don't know if it was his definition or not, but he talked about a functional programming language as one that treats functions as first-class citizens, right? So if you think about a functional programming language as a language that allows you to essentially use functions as primitive building blocks, similar to how you have like object-oriented programming languages that allow you to create objects, use objects as primitive building blocks. And then you have languages such as JavaScript, which I don't know what JavaScript is, but it's certainly not. Yeah, I don't know what it is, but it's just there. And unfortunately, it's just too much there. Yeah, anyway. You know, if someone had told me 30 years ago that I'm going to end up in a society where a lot of it is run by JavaScript, I would have just become a farmer. It's probably funny because it's true. Anyway, let's start. Enough talking. Okay, so if you're not familiar with Kotlin, everyone is. So this is a function, and we have type inference, return x plus y. Minor little thing, by the way, I saw on the previous talk. There was a minor little mistake. Where is that? There you go. Or who should I talk about with the mistakes? You said no. There was a mention of an inline function, which isn't actually what the slide was saying, because what it was representing, and because we'll talk about inline functions a little bit later on, but it was basically talking about single expression functions. So this is a single expression function in Kotlin, okay, which is different to an inline function. And single expression means that you could essentially write the entire function as a single expression. Given that most of us have 4K monitors nowadays, that's a hell of a lot of functions you can write, yeah? But that's a joke, by the way. So a lot of things also in Kotlin can be treated as functions, as expressions. So for example, if you're familiar with the if statement, you usually should use it as an expression in Kotlin. If you're familiar with the when statement, you should usually use it as an expression because it has some benefits. Okay, so let's talk a little bit about functions. So let's say that I have a function, just so that we're clear, this is a single expression function. This is a function that returns, the default type is unit, which I'm sure you're all familiar with. Unit is the same as void, except it's completely different because it is an object, right? So remember how I told you about JavaScript is just there? JavaScript has objects. And then if you were a C# or a Java developer, you went to JavaScript, and the first thing you said is like, I want my classes. And then we destroyed JavaScript by trying to bring classes. Kotlin has objects and it has classes. So this is how you implement a singleton in Kotlin, which is basically an object, okay? So that's the definition of your standard function, and you usually remove that. If you're not familiar with this, there's also something that you can do in Kotlin. If I write, for example, print line hello over here, and then I write ABC, this works, right? Yes? But if I do throw exception, blah, that doesn't work. Well, it works, it compiles, but it runs, it dies at runtime. So do you know how you can actually say to Kotlin that that function doesn't ever return? Nothing. Well done. Okay. So that's nothing, and now it tells Kotlin that it doesn't return, which is different than unit. Okay. So now let's talk a little bit about functions. So let me create a function called ABC. Now let's create a function. Let's be really what do you call it? Creative, and create a function called divide, and then I'll do return x plus y. Okay. And now I'll say to you, what is wrong with that function?
Why can't it zero?
The what?
The return type
What's wrong with the return type?
has to be double, or I don't know the that's right. Yeah.
Equal through divide by 0.
It could throw an exception, right? Okay, so now if I don't show you the code, what's wrong with that function? Well, assume it compiles. What's wrong with that function?
That's a return name.
What's wrong with that function?
Don't know the side effects.
Yes, I do. It's not doing anything. It's returning 0. The point was you don't know the side effects. Well, I do. It's returning 0. What is wrong with that function? It is doing what it's saying it's doing. It's returning an int. It's returning 0, right? However, if I had to return x plus y, everyone's like jumping up and down saying, no, that's wrong. That is wrong because it can throw an exception when y is 0, yes? But if I say, for example, blah, blah, and I don't show you the code of the function, now what are you going to say? Ooh, I don't know. It could be right or it could be wrong, right? And yet, because we are basically saying that we trust the signatures of the functions are going to describe to us what they are doing. And yet that function, if I call it blah blah, you don't know. If I call it divide, you're like, oh, well, I know that's wrong. Right? Why? Because you know what the concept of division is, and you know that if y is a 0, it's going to be wrong. Yeah? But blah blah, you don't know if it's right or wrong. So that is actually what's called what? A partial function, right? A partial function is essentially a function for which certain inputs there is no valid output. The opposite of a partial function is called a total function, for which any input there is a valid output. Now in maths, the synonym of a total function is, guess what? A function, right? So by and large in maths everything is valid and has, you can reason about. And this is the point. We want to try and reason about functions. So we don't do things like this. If I do a function, for example, get page, that has a URL and has a string, I used to know how to type, and I say if URL, and then it's this stupid butterfly keyboard, it is not empty, and return hello, else, throw exception, law. Okay? That is wrong. That's not the way we do error handling. That is absolutely wrong, right? Because we don't want to do that. Because what we do is we can say, for example, well, this could return a type result, right? So I have, for example, class result, and then I could have class success, which has, for example, the contents of type string, and then it has result, and then I have class failure, which could be failure, and then here could be the message, for instance, okay? Right? Now this gives me an error because in Kotlin you know that the types are final. So I have to declare it as open. I don't want to declare it as open because if I declare it as open, then what happens is that I can have, for example, another file over here. Let's say, I don't know, but let's go to live ADT over here, and I could say, for example, class. I was going to make a joke about what we normally say in Spain, but mañana kind of sometimes works, but it won't be funny here because we're in Spain. And never mind. So I can make a class that's called like sometimes. That sometimes it works and sometimes it not, right? So the way to fix that in Kotlin is to create it as a sealed, right? So sealed, basically, what you're all familiar with the word sealed? Yeah. Sealed, what it does is basically close the hierarchy on this, and then you know that you can't inherit from it anymore. So now I could do something like success here, and then over here I would do return failure and blah. Okay? So that's much nicer because it allows me to now kind of be way more explicit about my code, It allows me to be truthful. It is now, in fact, a total function, right? Because for all inputs, it is going to return what the signature says. So everything is wonderful, fantastic, and don't talk about like buffer overflows or anything like that. Now, how do I use this? So I can say, for example, s, get page, something over here, and then when s, and then is success, and then I would do print line s content, and when it is failure, I would do s message. And the nice autocasting in Kotlin makes it really nice for me. Okay, so what's the problem there? This is a trick question. There is no problem. But maybe there is. Anyone?
How to test?
What?
How to test?
Oh, we don't test. Testing is so overrated. You know, back in my old days, you used to just write code and ship it. And then if something was wrong, they would call you and say it doesn't work. You're like, don't worry, I'll fix it. And then break 3 other things. What is wrong with this? Well, I mean, there isn't technically anything wrong with it, but the whole thing starts to come here, right? Which is, okay, I've created a result type, yeah, and now this is way more explicit, it's way more descriptive, but it's also a lot of more code that I have to write each time. And if I have, you know, multiple result types and multiple functions that return different things, this starts to become a lot of code that I have to write. Now, of course, I could create a result type of type generic, and everything would be fine, and then I could create different result types based on my function, but this part of it, I have to write over and over again, yes? And it's like, could I kind of do something better there? So let's see. Well, let's take a look at some numbers, and we say numbers 1 to 100. Now we say numbers, and I say to you, hey, find me all the numbers that are divisible by 5. And what will you say? No, you won't, will you? You'll say numbers, filter, it, divisible by 5 equals 0. Yes? Okay? Why? Because you know filter. It's like there. Yeah? It's a function. And you've used it. And it's fantastic. But what is filter? It's just a function. And what does it do? It just abstracts some code. What code does it abstract? A for loop. It's not some magical, mystical thing. All it is doing is taking some concept, abstracting it into a function and saying, use this as a primitive building block. That's all it's doing. And now I say to you, monad, and you're like, go away. Like, no, I don't want monads. Those are too difficult. Okay, we won't talk about monads for yet. But take a look at this. Let's try and make this a little bit more concise. So instead of me defining every single time this result type, what if there was a data type that would allow me to do that? Now in my examples, I'm using a library called Arrow. How many of you have heard of Arrow? Okay. And I'm not going to give a disclaimer here that we support it or we don't support it. I'm just saying I'm showing you Arrow. Now, before there was Arrow, there was this thing called Functional, right? It was really cute because I think it was the first library that says, hey, let me replace the C with a K. And then that got really old really fast. So there was a library called Functional by Mario, and then there was another library called Category, yes, you guessed it, with a K, which was also another library by some folks at a company called 47 Degrees. And they decided to merge and create a new library called Arrow, which has a really, really CPU-intensive website. It's true, like the fan just goes every time I open it up. But it looks really nice. Look. It's JavaScript. If it was Kotlin to JavaScript, this shit would happen. So the good thing about Arrow is not the stability. The good thing about Arrow is that it's kind of modular. So you can use different things of it. By the way, is this being recorded? I always forget forget about this. I'm like, it's a close, small group of people, yeah. So the good thing about, no, it's a lot of love to them. They do a lot of experimentation. So the good thing about Arrow is that it's very, very modular, so you don't have to use everything. And I'm not suggesting, and I'm not saying you want to use, you don't want to use Arrow, it's completely up to you. It's just there, it's useful for me to explain some of the concepts. That's it. Up to you what you want to do. One of these is the data type, either, or depending on where you're from, either. So either is basically something returns either one type or another type. So essentially it's that result that we have, right? Whereas this way is, I'm saying that it can return either not applicable or a double. It can return one of these two things. And then you can say, well, if the country is Spain, then either left if it's right, otherwise return right. Now, either is a data type. It's not just a generic result. So what it does is introduce some other members to it. And one of them is this concept of a fold. And this is where things start to get scary. You're like, fold? I've never heard of this thing called fold. Is that like filter? No, it's just called fold. Forget it. Imagine if it was called if this then that. You know, like the service, if this then that? We should call it that. So fold. And fold, basically what it's saying here, for practical purposes for you to follow, is saying, if the result is something on the left, do this. If it's on the right, do that. All it is the same concept as filter. All it is just abstracting a function away, getting rid of the building blocks. If we actually dive into fold, oh look, it is a when expression, nothing more. Right? And yet, for some apparent reason, there's this psychological barrier that filter, map, and flat map is okay, but anything beyond that is just way too functional for me. Right? This is what I've often found when I talk to people. They're like, yeah, I use filter, flat map, and map, but don't push me anymore. In fact, if you know C#, Eric Meyer famously said that he introduced linked to C#, which is language integrated query, which everyone thought was a cool way to write SQL, because he wanted to introduce functional programming into C# but not scare away the developers. But if you look at select, if you look at where, all of these are basically filter, map, etc. Okay? So either comes, and then you have other things that come. For example, you have valid, which is kind of like a specialization of either, in the case of where something is either a valid computation or it is not. So if it's not a valid computation, it returns an error. If it is valid, it returns the actual result of that computation. Now, and then there's another one which is try, that's the great thing about Arrow. Every time I do this presentation, something else is deprecated. So try, for example, what it would do is try would allow you to essentially wrap some code that has some exception being thrown, kind of like legacy old stuff, wrap that into a try, and then essentially instead of throw the exception, what it would do is return the exception object. So you could query on that exception, right? So these are just data types that are available. And of course there's one data type which you're all familiar with, right? Because if we go back to our live functions over here, let's delete all of that. Let's say yes. What we have in Kotlin, of course, is the nullable type, right? So that's null, and then I could do length. And that is saying, well, this is a nullable type, so only apply this if it is not null. Only invoke this if it is not null. Now you could go a little bit further with Kotlin, and you could do something like, for example, use the built-in function let. Who's used let? Right. So what is let? It's just basically a function. Okay? It's a higher order function. So you could use this concept of let and then again do something, right? But it's very limited on what you can do with this, well, limited. It's for what it is. It's a type that can be nullable, and if it is not nullable, allow me to use the safe operator to invoke it, right? If you want to, so we also give you the option of shooting yourself in the foot, which is the double exclamation mark, for the times you miss your null reference exception. This is basically a specialization of the concept of option, which is of optional, which is concept of something being or not being, right? So here, the data type option is something that exists or it doesn't. If it doesn't exist, it is empty. And then I can use that in the same way. If I say, for example, process request, if the result is defined, do something. If it is not defined, don't do anything. Now, what we can do here, for instance, is now start to return a type option. So when I'm saying that the value exists, what I would do is I say it just returns x, y. Okay? If it doesn't exist, then it would return the empty. So nullability is a specialization of option in the case where the lack of a value is represented as null. And in the case of Kotlin, it is built into the language. And if you want to use it, it's absolutely fine. And no one is saying that you should use option. Okay? In fact, I generally don't use option. But option does give you some other things as well. And we'll see this. For example, here you can see again this whole, well, if the result is none, print something. If it is not, print something else. But we can start to combine this again with fold, right? And all of those things that we saw. But what happens when we start to use this option as the data type that we are passing in parameters? So let's say, for instance, here that I have a function called squareIt, which takes in an integer and returns an option. And I have another one, triple, which takes in an integer and returns an option. In this case, it's very straightforward. I'm taking an integer, I'm operating on it, I'm returning an option. But what happens when I want to, for example, do an option as parameter? Now I've got to do this when statement, right? If I want to do like some squareIt, I've got to do this when statement and say, okay, when the option is kind of like empty, don't do anything. If it has a value, then operate on it, right? Is there a way for me to make this in a shorter way without me having to do that? Yes, in fact, it's called map, right? You're all familiar with map? Yes, you've all used map. How do we understand map? Map is basically a function that takes a collection of items and applies a function to it. Yes, but actually what map really is the concept of a function that knows how to interact with the thing that it is encapsulating, with the actual data type, right? So, how many of you are familiar with monads? Okay, so now it starts to get scary. So monads is, I actually read a tweet a couple of weeks ago which said, I wonder if more people would have understood monads if we had called it the happy path. And if you think about it, that is exactly, essentially what it is, right? If you take a look at this function, which is map, essentially what this is doing is saying, if the value is just something, I will then operate on this just. If it is not something, then I will return empty. Now you imagine that you have this concept which is called a monad, which knows how to operate in the case that it's a happy path. You know what the concept of a happy path, no? The one we always program, not the one we always forget to program, right? So the concept of a happy path is kind of like that, saying, okay, well, I know how to go down the happy path. And if I know how to go down the happy path, if I could just pipeline all of my different functionality or transformations, as we were saying, then I know how to act. That is essentially the idea behind a monad, right? If you take a look at the implementation of a monad, it is nothing but basically, this is kind of like the maybe monad, which is the case of if there is a value that exists or if a value does not exist, essentially the option is also called a maybe, and it's saying, well, I know how to act on it. And the way that I do that is by implementing certain functions, which in this case is the bind and the fmap, okay? The bind in Haskell is basically a pipe symbol. When you want to do that in Kotlin, you have to use a little bit more kind of like something that's not a pipe. You can't do symbol overloading in Kotlin, so it doesn't become that pretty. But that's something that also actually the Arrow team are working on to try and make this a little bit more pretty. Okay? So what we're doing is basically taking these functions and using them as primitive building blocks to create more functions and use those functions. So where else could we go here? Well, before we go further, let me just talk shortly about immutability in Kotlin, right? We have immutability as we know it in terms of val, right? So Kotlin, as you know, by default, it doesn't enforce immutability. It highly recommends it, right? How does it highly recommend? In fact, this is a true story. If you take a variable called blah blah, you notice that it's underlined, right? Have you ever thought about why it's underlined? Because that annoys you. If you think about it, underlined code is horrible. Like, you don't want to see code that is underlined. So we did that on purpose. We're like, yeah, you don't want that. Yeah. So make it val, and then it'll be okay. See the underlining goes. Right? It's really a true story. So we kind of encourage immutability. Now, the problem with immutability is that, well, yes. Oh, by the way, talking about testing frameworks, thank you for not mentioning another one that I started. It's like my work never gets any value here. Okay, people, has anyone heard of spec framework?
Yes.
Who uses it? Can you all put up your hand a second, please? Just for me. Put up your, all, everyone, raise your hands. I'll tweet this. Let's look how many people use spec. Well, I mean, looking at it this way, it's a good thing I stopped working on this a few years ago, because that would have been a waste of my life. So yeah, this is spec. It's kind of cute. Yeah. Anyway, where were we?
It
Yeah.
has two versions.
Pardon?
It has two versions.
Yes. Yeah, but that's not my fault. Yeah, it's also migrating to 2.0. Yeah. It's kind of like, you remember the whole story about AngularJS? Yeah. How to migrate from 1.0 to 2.0 in 6,725 steps. So, this is great, but when we talk about properties, obviously you've got to be careful, because this is an object, it's immutable. Val is immutable. This is not immutable, although it's a val, right? Because that is not immutable. Yeah? If you want to make it immutable, you have to write const. If you put const, then that no longer is valid. It has to result to an actual expression. Okay? Now, in terms of collections, in Kotlin, as you know, we take Java's collections and we essentially put wrappers around them. So for example, if you want to create a list, you write list of, which is again encouraging immutability. If you want to write a mutable list, you would have to write mutable list of, right? Which should be basically renamed to mutable list of, kind of like following here saying, are you really sure you want to do this? We are actually creating our own collections as well. There's a project on GitHub which is called Kotlin, guess what it's called? Kotlin X Collections, yes, you guessed it. Which is basically allowing you to create certain collections that are immutable, but copy them easily, etc., etc., and create new collections out of them. That's in very, very experimental stage right now. So when it comes to immutability, this is important. And why is immutability important? Because if you go back to this scenario here, when I ask you what does this do, one of the biggest issues is what? The moving parts. You have so many moving parts that you have to basically try and interpret this yourself in your head. You become the runtime. And what we want to try and do when we are working with functions is to try and create functions that are pure. That means functions that, whether I run them one time or a million times, always produce the same output. This then leads me to referential transparency, which essentially is another way of saying, if I were to take my function and replace it with a lookup table, it would have the same effect. It wouldn't really change the behavior of the program. And we'll see why this is useful. But let's go back to functions and see what else we can kind of do with them. So we've seen that we can take functions and we can pass them around, right? If we went to live functions over here, you saw that we created these functions. So for example, sum x int, let's just make it with a sasum, whatever that means, return x plus 1. And if I were to create a higher order function of that, I would say, for example, I've got a function f that takes an integer and then returns int, and then what I could do is call that with ho, and this would be sasum, right? Or I could use the lambdas, as you know, we've seen, right? In all the things we've seen over here, that could actually be is plus 1, yeah, because it's a single expression. Then we take this out, we get rid of the brackets, then we can do this multi-line, all of this, right? This is everything that we've basically seen in Kotlin and how we define higher order functions. But so far, all we've seen is actually how to pass functions to functions. And a higher order function is a function that takes a function as a parameter or returns a function as a parameter. But what else could we do with these things? Well, one thing that we could do is if we start to treat functions as primitive building blocks, we might be able to do other things such as composition. So let's take a look at this. This is 3 lambdas, right? Lambdas, if you're not familiar with that, you are. Lambdas is the same thing as anonymous functions, right? Yes? No. In fact, in most languages, yes, not in Kotlin. And if you go to Wikipedia, it'll probably say that is the case, but screw Wikipedia, because even sometimes they don't care about facts, they're more worried about their moderators. And if you don't know what I'm talking about, look up La Voz de Galicia. There's a recent article which involves me and Wikipedia. Anyway, come on. Yeah. I had a run-in with Wikipedia. So take a look at these 3 functions. There's source, which takes a string and returns a path, prefixing it with data. There's all lines, which takes a string, basically a file, and returns all of the contents of that file. And there's another one which takes a list of strings and finds everything that matches. And if you were wondering, no, I did not write that. Yes, I did look it up on Stack Overflow. I don't know how to write regular expressions, and it's something I'm very proud of. So I say to you, okay, you know what? Here's what I want you to do. I want you to create a function for me that basically what it does, it combines these, right? It combines it. So you can say, okay, well, I'll just take file name, get the source, I'll take all lines, pass in that, and so on and so forth, and I'll create a new function to do that. And now I can go and call this function. But do I have to create this new function and this create new block? Or could I use this some other way? Well, you could actually do functional composition, right? So in this case, what I'm doing is saying, I'm creating a new function, which is say, take my function find matches, compose it with all lines, and compose it with source. What is compose? It's a function, but what type of function? Infix, right? You're familiar with infix functions, right? Infix functions are basically functions like this, right? String infix, basically you can call it an infix notation. So what this is doing is actually creating a new function that is taking all of those functions and then allowing me to call it. It is composing them. In Haskell, that is done with a dot. Here, it's done with the function called compose. And if we take a look at compose, it is essentially a function that is doing what I said. Take that function and compose it with another one. And the only condition that you need to match is essentially, for functional composition, you say that if I have a function that takes an x and returns a y, and I have another function that takes a y and returns a z, the parameter output type of this has to match the input type of that. As long as it does that, in principle, I should be able to combine these functions. So now it's not just about passing functions in and out, I can now do functional composition and combine multiple functions that I have into new functions. What else could we do? Well, what about piping? So let's say that I have this function over here, which is called list, that takes a list of strings, and it returns a list of strings. And then I have another one that takes a list of int strings and returns an integer. And I say to you, you know what? I want you to take the first process, so I can say, for example, first process, list of, right? And I want you to call second process on that. And you're like, well, I can't. Why? Because second process is not part of list of string. So I'll say, well, you know what you could do is you can create a list of string extension function to second process. But that starts to become tedious. You don't want to do that all the time. Right? If all I want to do is pipe the results of one thing to another, just like I could do with filter map, right? If I have filter map, I could do n filter, it is greater than 10, I can do map, I can do all of these because these are extension functions on iterable of t. So these exist, right? Everything is an extension function on iterable of t, I could do that. What if I don't have that ability? Well, you can use intermediate variables if you want. Or you could just create a function called pipe. That all it does is take the output of one, pipe it into the input of the other one. So here, for example, I have a list of objects, and here I have elements, and I say first process objects, pipe to second process. What is pipe? It's just a function that takes another function and returns a function. And you can see that you have pipes up to 22 parameters. Now, if your issue is that you don't have one for 23, that is not your issue, man. Okay? Your issue is like, oh, why am I going down? No, stay up here. Stay in the happy zone. Not here. This is horrible. You don't solve this problem with named parameters. No. Stay here. Okay? You know what you can do if you've got too many parameters? You can pass in a data class, or you can abstract it into another function. Okay? Don't try and see how far you can go. So, now, I can do some other things as well here. So, how many of you are familiar with the concept of curry? Okay, so curry, basically what it means is that if you take a function, a language such as Haskell, Haskell is by default curried. That means that every function only has a single parameter. And when you actually have a function with multiple parameters, what it is doing is actually kind of creating intermediate functions that are creating single parameter functions, right? So if I have a function sum, which takes 2 parameters, and I call curry on it, what do you think that is going to return? A function. So if I run this, you can see that is going to return a new function with a single parameter. And if I call sum curry to 3, what is it going to do? Well, this is now a function with a single parameter calling another function with another parameter, which is then going to give me the result 5. Now, why would you not want to know this? You don't, but it looks very, very cool. Okay? There are some applications of this, such as partially applied functions, which is different to partial functions. So you're all familiar with object orientation, and you're all familiar with dependency injection, right? Okay, so dependency injection is what? Well, I thought you're all familiar with it. Is it Dagger? Apparently, according to Google, if you want dependency injection frameworks, you've got to use Dagger. Yeah, I know. That's what a lot of people in the audience said. But anyway.
If it's simple, you can.
Yeah, if it's simple, you can do it by hand. Yeah, I love the like the chart. If it's simple, yes. If not, use Dagger. Screw everything else. But here's the thing: if you take a look at dependency injection, right? Dependency injection, all it's essentially doing is basically passing in some class to do some behavior, right? So if I don't have a class, let's say that I'm now moving towards functional programming, and in functional programming I'm essentially, creating functions, and everything I have are functions, and I have no classes, and you're like, whoa, how do I do dependency injection? You don't. Well, how do you do it? Well, you pass in a function. That's how you do it. If you look at it, a lot of times when we're doing object-oriented programming, we're actually not doing object-oriented programming. We're just passing around behavior. There's a very good article by Steve Yege, I don't know if you've read it, which is called Verbs in the Kingdom of Nouns. Nouns referring to objects, verbs referring to behavior, to methods. And it talks about how much a lot of the ceremony that we have is around creating these nouns just to pass in behavior. To give you some examples of this, right? If I say, for instance, the filter, right? Customer filter. Worst case, a lot of times this is implemented as customer repositories, which is the very wrong pattern of repository. But I say filter by name, filter by country. These 2 blocks of code are exactly the same. The only thing that differs is the actual condition. That is why we can just pass in a filter with a higher order function. If we take a look at the strategy pattern, you're all familiar with the strategy pattern, right? The book Gang of 4, right? Before, if you said I'm a software developer and you hadn't read the Gang of 4 design patterns, people would question your integrity. Now you have to hide saying you've read that book. Now it's like the anti-patterns, which I don't agree with. But anyway, but if you take a look at, for example, the strategy pattern, right? I declare this interface, I declare this class quicksort, bubble sort. All I'm actually doing is just passing behavior. And if one of the ideas behind functional programming is to minimize state, is to not have side effects, is to have pure functions. If I get rid of the state that a class is holding, then all it becomes is really behavior. So then why do I have this ceremony of the class? Why can't I just pass in that behavior? And this comes now back to what we were talking about, which is, okay, so how do I do something like the equivalent of dependency injection where I want to somehow change that behavior? That's where the idea of partially applied functions comes in useful at times. So partially applied function essentially is the same concept of how you have default parameters in functions, but what you could also do is try and create default functions with some parameters set. So in this case, if I have a function sum and I do partially 2, what it is doing is creating a new version of a function for me with the first parameter set to 2. So here, if I run this code, you can see that my first parameter is function. It is returning a function, and the second parameter is basically returning that function as if the first parameter was set. This allows me to now set different types of functions for different scenarios and have different behaviors, much like a dependency injection framework would have. Now the difference of course here is that you don't have the discoverability. Like one of the things that I've always used IOC containers for is the ability to create like plugin architectures, right? So you could just dump some jar or some DLL somewhere and it can discover some functionality. So things still have their place there. Okay? So these are some of the things you can start to do with functions. Now, when you start to talk about functions, one of the topics that often comes up is, okay, this is all great, this is all wonderful, but what happens when I have all of these functions? What happens when I'm now having multiple functions that are calling other functions that are calling other functions that are calling other functions? My application is not going to be performant. In which case, normally the response to that is, yes, but first look at your database access, then look at your bandwidth, then look at your algorithms, then look at it. And then once you're through everything, then start the optimization of functions. However, having said that, there are some impacts. So if you actually take a look at a lot of the functions in Kotlin, and if we go to live functions, you can see that many of them, so if we create a function here that's called ABC, I'm going to, if you don't mind, since you don't ask questions, I'm going to run into my 10 minutes. Can I run into my 10 minutes? Great. Any objections? No. So if I create a function called ABC, and I have, for instance, x int, I can add this thing called inline. Okay? Now, if I add this thing called inline in Kotlin, it gives me a warning, and it says expected performance impact of inlining is really not significant, right? So then if it's not significant, why do we have it? What exactly does inline do? Are you familiar with that? What? It copy-pastes the code, right? It's a very fancy way of saying copying and pasting code. So why would I have that? Well, inlining really has many benefits when we're talking about higher order functions. So if I were to add a higher order function here, now it doesn't complain anymore because it allows me to actually inline that code. Okay? So it's not only inlining the function, but it's also inlining the lambda. Okay? Now there's also the ability to create another function. Let's say that I have another function that I'm passing here that is unit, and I have another word that I can use which is called no inline. Which, what does that do? It doesn't inline. Right? Inline inlines, no inline does not inline. It's like amazing, huh? So why would I do that? Well, here's the problem. When you inline, I can call that function. I can't assign that function to anything. And yet, if I want to be able to assign the function, it has to be non-inlined. Okay? Now this has some consequences. This is good because it basically copies the code, so there's no additional call there, right? It's essentially copying and pasting the code. But let's look at something. So let's do something, and then we'll do, for instance, val numbers equals, I'm going to be really, really creative here. Instead of 1 to 100, I'm going to say 1 to 50. So numbers filter, if it is divisible by 5, then return. what am I doing wrong? If it is desired by 5. What is the error here? What am I doing wrong? Something I'm doing wrong. Numbers.
It's expecting Boolean here.
3 what? Hold on. Oh, hold on, no. I don't want to do filter actually. Stupid me. If it is divisible by 5, return. Okay? And now main do something. Now if I run that, what's the output? The output, like what does it print on screen? Who says nothing? Who says hello? Who says it's me? So some say hello, some say nothing.
Nothing.
Nothing. Why nothing?
Because you are returning from the function.
I'm returning from the function. Okay, why? So you're saying that it returns not, it doesn't print anything because it doesn't reach this line, yes?
Yes.
Because it's returning from here. Why? Exactly, not because the docs say it, but because for each is in line, right? Since it's in line, there is no internal function, right? There's only the function on the outer scope. So if I want to, that is called a non-local return. If I want a local return, I would have to do return at for each, right? Or use another label, or explicitly put a label. So that has that effect as well, which takes me to the other thing, which is when I have a function, which I have, for example, an f of a unit, and this is in line, and then we have a g of a unit, and I said to you that there is a no in line. There's another one as well, which is called cross in line, which I'll leave as an exercise what it means, but hint, it's related to the behavior of returns. Okay? So, first of all, we do the optimization around inlining. So if you have arrow order functions, if you look at the majority of the functions in the standard library, if you look at the majority of the functions in Arrow, most of them are inlined. So there isn't that issue. The other thing is tail call recursion. Okay? So, are you familiar with recursion? Of course you are. Recursion is a great way to recursion is a great way to express things because it's very clear how you can define. It's very clear to express intent. It's much easier often to comprehend code that is recursive than the iterative version of it. This is a factorial. The problem with that recursion is also kind of slow. So when you have tail recursion, which means that the last call to a function is to the function itself, you can do what's called a tail call optimization. Haskell, again, is something that does that out of the box. With Kotlin, you have to be explicit. So if you have a function that's tail call recursive, which in this case this one isn't, you would have to convert it to tail call recursive. So basically passing an accumulator, you can then add the tail rec. And what tail rec does is essentially convert that into a loop, right? It does the optimization into a loop. But remember when we talked about pure functions, functions that do not alter side effect, functions that then lead to referential transparency, which means that you can essentially replace it with a lookup table. So that's where this idea comes in mind as well. Fibonacci, you all know Fibonacci, no? Right. So I show you this code and you'll say, oh, I know, this is a Fibonacci sequence. I show you this code and you have to think about it a little bit before you realize that it's a Fibonacci sequence. Now the difference is that this one is very well expressed. This one is a little bit harder. But the difference is that this one is also much slower, right? If I were to do Fibonacci of recursive of 10, I can run this and it's pretty fast. If I put 50, I can promise you that we can go, have our beers, come back, and this is still running. Okay? And the problem is that for each one, it is calculating multiple times the same value, right? Now, if I were to do Fibonacci iterative for 50, that is immediate, right? It is immediate. But it's harder. But if we have a function that is pure, a function that every time it runs returns the same value, why couldn't we, for each run, memorize the value of the computation? And that is a technique called memoization, right? Again, Haskell does memoization. Kotlin does not. Here's a naive implementation of it. In fact, I think Arrow now comes with the ability to memorize functions. But here is, yes, I know that this has side effects, but let's just don't go there. This is naive implementation of a memoization of Fibonacci, which essentially is saying, I will look up the value if it's already been calculated. Each time I calculate a value, I will store it, and then I will look it up. So if I were to run this, memoized, how long do you think that would take? Pretty much the same as iterative. So it gives me the expressiveness of recursion, but it doesn't give me the overhead of recursion. And this doesn't need to only be applied, obviously, to recursive functions, right? Because recursion is, I'm using this as an example because you know that Fibonacci is very, very slow, so you can really see the difference. But this can basically be applied to any idea, any function that essentially is pure and allows you to, when you run it multiple times, it always gives you the same value. Okay? So this is kind of like an overview of functional programming with Kotlin. You can see that there's a lot that's already built into the language as part of the standard library. There's a whole bunch that isn't, but you could use Arrow, you can create your own data types, you can create your own small little functions. I mean, a lot of these ones, like for example, partial functions that I showed you, is again very easy to create, right? Partially is, yeah, again, don't go down there. But it's very easy. Okay, and I did say to you that I'm going to show you one last thing, and we've got a couple of minutes left, right? Yes. Okay. Because I said that we didn't see this in the other session, and one of the great things about Kotlin is the ability to create DSLs, and you saw that, for example, in the routines, right? How many of you have actually created DSLs with Kotlin? Okay, for those of you that are not familiar with DSL, DSL stands for domain-specific language, right? Which is a language that is specific to a particular domain, and that's how I explain things, right? So let's say that I'm going to do some DDD, which is DSL-driven design. It's not domain-driven design. But that's the idea behind it. If you're familiar with domain-driven design, we talk about ubiquitous languages. We talk about aligning the language that we use in our software with the actual business needs, right? And what better way to do that than creating DSLs? So let's say, for example, that I want to do a DSL that has to do, for example, something simple like a configuration, right? So I'm going to create a configuration. No, let's create something that I don't actually have. So let's say I want to do, for example, cloud. We love the cloud, right? So I want to create a cloud, and I'm going to say, for example, a provider. And the provider is going to be like, let's say, Google Cloud Provider. And then Google Cloud Platform. Is it P? Provider? Yeah, platform. And then, for example, I say machines, right? And then here I can say, for instance, CPU equals, I don't know, big. Memory equals ability to run Slack. And description, well, we'll forget this. Okay, so now let me try and deduce how I would actually implement this DSL out of this code, right? And the great thing about this is that you don't even need to know Kotlin. You just need to know Alt-Enter. So I'm going to create a function called cloud. Okay? So here, now I'm like, okay, what do I take as cloud? So let me think about this. Well, it's got some properties, so I can create, for example, a class called cloud. And we'll create a data class here called cloud, and then we'll say, for example, it has a provider string, and then machines, which is machine, and that will initialize to, and then we'll have a data class machine that has a CPU of type string that will make empty, and then memory of type string that will make empty as well. Okay? And we'll do that one. And what's wrong with this one? Machine, bar, machine. Okay, so I've got that, but that doesn't actually provide me with much, except if I were to now treat this as a higher order function, so I can say, well, this takes a cloud and it returns a unit. Okay? But that still doesn't solve my problem, because I need, these are properties of cloud. So now if you know Kotlin, you know that if a lambda has a single parameter, I could pass it in as it, right? So I could come here and say it, and so on and so forth, and get some better ability there, but that doesn't look too nice either, right? So let's get rid of this. Now, you're all familiar with higher order functions, yes? You're all familiar with extension functions, yes? So now imagine if an extension function is a function. What happens if I take an extension function and pass in an extension function to another function? It is a higher order function. In Kotlin, that is called a lambda with receiver. So it's a higher order function that is passing in an extension function. How do I express that in Kotlin? What I do is I take the type, just like when I create a function that is an extension function, I say prefix the type. I do the same here. I say cloud dot, and now I magically have my provider. Okay? Because now this is an extension to cloud. Since it's an extension to cloud, the lambda has access to the properties of the cloud. Okay? But here is another problem, which is machines. Machines is not a function. So I could hit Alt Enter, but it's like, okay, well, what do you want to do? Create a function. I don't want to create a function. This is an object. Can I invoke an object in Kotlin? What? Sorry. No, go ahead. Yeah, I can. Yes, I can. So if I have a class, for example, called foo, what I could do is come here and I could create, for example, let's say that, yes, no, okay, yes. I could do, for example, foo, right? And then could I do something like foo? I could do that. I would just have to create a member function called invoke and define it as an operator. As soon as I do that, now I can invoke that object. So let's do the same thing here. I can do create member function machine invoke. Now what do I pass in as parameter to machine invoke? The same pattern. I want to have access to the properties of machine. Therefore, this should be a function that takes as parameter machine extension function. And suddenly I've got my beautiful DSL. Okay? So now you don't do this in production code, because one thing is that these are all vals. These are all vars, and we try and stay away from var. But this is very simple solved, right? What you essentially can do is create these as val and then create a builder pattern that essentially creates the instance for you, right? You have some intermediate functions that allow you to do that. Okay? But this, and I think I've got like I don't have it. No. I thought I had it. Basically, you, what?
You have a DSL 5.
I have DSL, yeah, but I'm betting you. Oh, DSL done. There you go. Thank you. Awesome. So yeah, so basically this is an example of a DSL where I have, for example, configuration host, port, filter, name, description, and here you see it's using val. and what I'm doing is I'm creating these configuration builders. I use the annotation that it says that it's actually a configuration DSL, and basically the builder is returning the type. Okay? So there's a cleaner way to do this. The DSL marker is another annotation that is used to then limit the scope of what you can actually create at certain levels of the lambdas. Because, for example, here, I don't want to be able to create, for instance, provider at this level, right? I don't want to be able to do that because provider belongs to the top higher level lambda. So it defines the scope to which that property belongs, is accessible. Okay? So although that's kind of falls outside of the scope of functional programming as we know it, it does use functions, it has the concept of lambdas with receivers, and it's another thing that you could use do with Kotlin as when you use functions as those primitive building blocks. And now I'm done. Okay. Thank you. So I don't know if there are any questions, but I'm guessing that you much prefer the beer than the questions. But I'm going to be around for a little bit, so.
Actually, Hadi was avoiding questions for 3 hours. Maybe at least one question for him. No? Lucky you, Hadi.
It's crazy because, like, you know, I would have thought that of all countries in the world, you know, in Spain, it would be kind of people talk more. But it's like, I mean, I go to different countries and I have different audiences in front of me, and it's not, I'm not trying to be insulting or stereotyping anyone or anything, but like, you know, there are countries like Sweden which people are generally quiet. There are countries like Finland where at times I've had to come off stage and touch the pulse of some people to see if they're still there. And it's amazing because they look so serious and pissed off, and then they come out to you afterwards, they're like, that was a really good session. I'm like, thank God, I thought you were going to kill me. And I always thought that like in Spain there'll be more interaction.